Of a function, is it visible? Okay, very good. Okay, all of you please see the today's class. I am discussing about the derivative of the function of complex variables. Before that, in the last class we discussed the limit of a function. Limit z tends to z naught, f of z is equal to L when the function f of x we consider. So in the epsilon notation also we discussed in the last class. So now I'm telling about the definition of continuous function. A function f is continuous at a point z naught. If limit z tends to z naught, f of z is equals to f of z naught at that particular point. There the function value is equals to the limit of the function value. Both are equal, then we call it is a continuous function. This is also we discussed. Some two problems we discussed on this one. Today's class I am discussing about the derivative of the function. Derivative of the function of complex variable. All of you please write down. Suppose the function, the complex function f is defined in a neighborhood of a point z naught. The derivative of f at z naught is given by f dash z naught, that is equal to limit delta z tends to 0. This delta z tending to 0, then the function value becomes f of z naught plus delta z minus f of z naught by delta z naught. The increment of the delta, the increment of the function at the point f of z naught minus that function value at that point by the delta z naught value we consider. This is the derivative of the function at that point, provided the limit exists. If this a limit not exist, then we call the function is not differentiable at that particular point. Okay, and if the limit in 3 exists, f is said to be differentiable at z naught. Also, if f is differentiable at z naught, then f is continuous at z naught. This is I discussed in the last class. This is I discussed. Okay, మీకు చెప్పాను డిఫరెన్షియబుల్ ఎవ్రీ డిఫరెన్షియబుల్ ఫంక్షన్ ఈజ్ కంటిన్యూయస్. నేను tan x ఇన్ఫర్మేషన్ కూడా ఇచ్చాను, mod x information also I gave. So these functions are, you see that every differentiable function is continuous, but every continuous function need not be differentiable. Need not be differentiable. This is, you remember it. Okay, కావచ్చు కాకపోవచ్చు differentiability. కానీ if it is a differentiable function, definitely 100% it is a continuous function. There is no doubt at all. Okay, what are the rules of differential equation for complex functions? The constant rule I'm writing here. What is the derivative of the constant function? That is 0. As in the real functions also, the derivative of the constant is 0. Here also the derivative of the constant function is 0, and the derivative of a function which is multiplied by a particular constant, then this is equals to, you take this constant outside and you differentiate the function, both are equal. Okay, so this is, it is telling. So that means what? If suppose the derivative of the real functions, how we take the derivative of 2x is equals to 2 into derivative of x. The same way, the derivative of the constant function into f of z is equals to c into the constant into the derivative of the function f of z. Okay, that is we write as f dash z. Okay, what is the sum rule for complex functions? You consider two complex functions f of z and g of z, and you apply differentiability on these two functions. When you take these two functions in a bracket, each function you differentiable and you add, both are equal. That is the meaning of this one. So that means f of z plus g of z you are adding and you are differentiating, that is equals to f of z differentiability. This is adding with the g of z differentiability. Okay, this is we call as sum rule. Next, product rule. D by dz of f of z into g of z. F of z, g of z, two functions. When you take these two functions, you are applying differentiability. This is just like UV rule, what we apply in the real functions, the same thing we are applying here. First you take f of z as constant and you differentiate g of z. Okay, keep it in that way. Plus again you take g of z as a constant and f of z you differentiate with respect to z. That is f of f dash z. Okay, so this is we call as product rule. This is a UV rule. Next, quotient rule. U by v rule. U by v rule. Two complex functions, whenever you consider and you differentiate, that is equals to g of z into f dash z minus f of z into g of z by g of z. The denominator value you take as a square. This is we call U by v rule in real variables. The same thing we apply in the complex variables. Next, chain rule. Obviously, these things again you can write. Definitely, this is also applicable for real functions and complex functions. Therefore, every time you keep it in your mind. So d by dz different g of z. That means the function contains inside a function. Okay, differentiate just is like f dash z, like that one only, and inside function you differentiate and you multiply with f dash z. Okay, that is f dash g of z derivative. So this is also one of the rule, chain rule we call. Usual rule, this is z to the power of n. If this is a in x to the power of n you have in the real functions, the same thing, but x is a variable in the real functions, but in the complex functions, the variable means z is a variable. Z contains two inside the variables x and y, and one is the real variable and the other is the imaginary variable iy. Okay, x plus iy is z. So d by dz of z to the power of n, the same thing what you apply in the real function, then the same way n into z to the power of n minus 1, n an integer. These are the 9 rules you have. These rules are very important. So using these rules only, we solve the particular problems. For example, one problem we solve, then you will understand the concept. F of z, uh, Uh, okay. F of z is equal to 3z to the power of 4 minus 5z cube plus 2z. And this is the second question. This is the question I'm discussing here. This is the question. Okay, all of you see here. Simply what we are differentiating this function the same way in the real functions how we are differentiating, that is the same way we are differentiating. So f dash z is equal to 12 z 3 4 ja 12 z cube minus 5 3 ja 15 z square plus 2z derivative is 2. So this is the answer. Okay, so this is the answer. The second one is f of z is equal to z square by 4z plus 1. This is we apply u by v rule. D by dz of u by v rule we are applying. So this is equal to what? So u into u. You see that. So this is v. V is constant and the derivative of u minus u constant derivative of v, this by v square. This is the formula we are using. You see here 4z plus 1 is a constant. We treat as a constant, like that we are writing, and z square derivative is 2z minus z square we treat as constant, and 4z plus 1 derivative is 4 by v square 4z plus 1 whole square. So this is equal to 4z square plus 2z by 4z plus 1 whole square. This is the answer. Next. So next I am discussing about the analytic function. This is very important in complex variables. So what is a analytic function? So a complex function w is equal to f of z is said to be analytic at a point z naught. అంటే ఇలా ఒక కాంప్లెక్స్ ఫంక్షన్ తీసుకొని ఈ పాయింట్ z naught అనుకుంటే, ఇది z naught అనుకుంటే, at this point the function is analytic. The function is analytic. So if f is differentiable at this z naught, so at this point the function is differentiable, and at every point in some neighborhood of z naught also it is differentiable, some neighborhood of z naught, some neighborhood of z naught. Okay, some neighborhood of z. ఈ నైబర్హుడ్ లో ఈ పాయింట్ ఉంది కదా, ఈ నైబర్హుడ్ లో డిఫరెన్షియబుల్ అయితే ఈ మొత్తం నైబర్హుడ్ లాగా ఈ కొంచెం సమ్ నైబర్హుడ్ ఆఫ్ the function it is differentiable, then we call the function is a function is analytic at every point of z is said to be an entire function. Polynomial functions are entire functions because every polynomial function is entirely differentiable, everywhere differentiable it is, therefore it is an entire function. That means if suppose you see a function, this is a z naught, in this neighborhood, if suppose I am taking in this పెద్దగా మీకు ఈ చిన్నదాన్ని నేను పెద్దగా ఎన్లార్జ్ చేసి చూపిస్తున్నాను. At this point the function is analytic means what? Everywhere in this domain, in this neighborhood, it is the function is analytic. If suppose every point of z means z naught point is z naught neighborhood is, if suppose this is the neighborhood of z naught, this is the point z. So if suppose this point the function is analytic means what, again some neighborhood of this one. For this one, this point is analytic, and this point the function is analytic means what, this some neighborhood the function is analytic. Okay, if suppose this point the function is analytic means what, some neighborhood of this point the function is analytic. You see that? So in this way, if suppose the whole neighborhood, if you take like this one, everywhere the function is analytic, this point, this point, this point, this point, like this one, everywhere the function is analytic, then we call it is a entire function. It is a entire function. ఎక్కడ బయటికి పోయి చూడు, బయటికి పోయి చూడు. So this is the way a function is analytic at every point of z means it is analytic in entire in this domain. Its entire domain, the function is analytic. Every point of z is the function is analytic. Then we call the function is entire function. The main good example for entire function is what is the entire, such kind of problems you will get in the examination. So they will ask only that. So define the entire function. Entire function. Okay, entire function. What is entire function? And give an example. Okay, then you write down the function is analytic at every point of z is said to be an entire function. And the example is, good example is this one. Polynomial functions are entire functions. Okay, this one. Analytic function means what? Analytic అంటే ఏందండి, ఇక్కడ మనం మామూలుగా రియల్ అనాలిసిస్ లోపట ఏమంటాము, డిఫరెన్షియేషన్ ఆఫ్ ఏ ఫంక్షన్ అంటాము, డిఫరెన్షియబుల్ ఎట్ ఏ పాయింట్ అంటాం, అంతే కదా. ఇప్పుడు మీకు రియల్ అనాలిసిస్ లోపట ఏముంటది, sin x ఈజ్ ఏ డిఫరెన్షియబుల్ అంటే ఒక పాయింట్ తీసుకుంటే ఇన్ ద డొమైన్ ఆఫ్ ది sin x at that point the function is differentiable అని ఎప్పుడు చెప్తాం. సో at a point if you take and right limit left limit exist, both are equal, then the function is differentiable అని చెప్తాం మనం, అంతే కదా. ఈ డిఫరెన్షియబుల్ అనే మాటనే తీసుకొని వీఆర్ న్యూలీ గివింగ్ ఏ డెఫినేషన్ దట్ ఈజ్ అనలిటిక్ ఫంక్షన్. అంటే అనలిటిక్ at a point, analytic function. What is the difference? Analytic at a point means at a point the function is differentiable. అంటే మీకు రియల్ అనాలిసిస్ లోపల ఈ అనలిటిక్ అనే మాట వాడము, కాంప్లెక్స్ అనాలిసిస్ దగ్గరికి వచ్చే వరకు ఈ పాయింట్ వాడతాం. ఎందుకంటే రియల్ అనాలిసిస్ లోపల సింగిల్ వేరియబుల్ ఉంటుంది, కాంప్లెక్స్ అనాలిసిస్ లోపల ఒక పాయింట్ అంటే ఏమంటున్నాం మనము, x plus iy, two variables ni kalpesi we are telling that it is a point, it is a function అని చెప్తున్నాం, x plus iy. సో w is equal to f of z is a function అంటాం మనం. కాబట్టి ఇక్కడికి వచ్చేట వరకు డిఫరెన్షియబిలిటీ అంటే x దగ్గర x ప్లస్ iy అనేటువంటి పాయింట్ దగ్గర డిఫరెన్షియబుల్ అంటే x ఈజ్ డిఫరెన్షియబుల్, y ఈజ్ డిఫరెన్షియబుల్ అన్నట్టే కదా దాని అర్థము. సో ఆ పాయింట్ల దగ్గర తీసుకోవాల్సిందే కదా. అందుకోసమే ఇక్కడ న్యూగా మనం డిఫైన్ చేస్తున్నాము అనలిటిక్ ఫంక్షన్ అని. బట్ there is no change at all. It is a differentiable. Analytic at a point means మీకు differentiable at a point అంటాం మామూలుగా రియల్ అనాలిసిస్ లో. differentiable at a point. ఇక్కడికి వచ్చే వరకు analytic at a point. What is the meaning of analytic at a point? It is a differentiable at that point. దాన్నే ఇంకొక రాగా మాట్లాడుతున్నాం అంతే తేడా. బట్ both are same. Analytic at a point means what? The function is differentiable at that point. And okay, if f is differentiable at z naught. Okay, అయితే ఇక్కడికి వచ్చే వరకు ఏమవుతుంది, ఎక్స్ వై రెండు ఉంటాయి కాబట్టి ఆ జెడ్ నాట్ ని, జెడ్ నాట్ అనేది పాయింట్ ఎట్లా తీసుకుంటారండి, ఈ విధంగా ఉంటుంటే ఇలా కదా నైబర్హుడ్ తీసుకునేది. రియల్ అనాలిసిస్ లో ఎట్లా తీసుకుంటామండి, ఎక్స్ అంటే ఇది నైబర్హుడ్ గా తీసుకుంటాం. అదే మీకు కాంప్లెక్స్ అనాలిసిస్కి వచ్చేటరకు, కాంప్లెక్స్ వేరియబుల్స్కి వచ్చేటరకు ఏం చేస్తాము, ఎక్స్ వై తీసుకొని ఒక పాయింట్ అంటే జెడ్ నాట్ అనుకుంటాం ఈ పాయింట్. ఓకే, ఈ పాయింట్ జెడ్ నాట్ అంటే ఏమవుతుంది, ఇప్పుడు మీకు ఈ నైబర్హుడ్ వచ్చేసింది. ఈ నైబర్హుడ్ ఈజ్ ఏ ఓపెన్ బాల్. హియర్ నైబర్హుడ్ ఈజ్ అన్ ఇంటర్వెల్. దిస్ ఈజ్ ఎక్స్ నాట్ అనుకుంటే at this point the function is the differentiable means what? Right limit and left limit, or left limit and right limit both are equal, then the function is differentiable at this point. But the function is differentiable at this point means what? At this point only the differentiability. But analytic అని ఎప్పుడు అంటున్నాం, ఇక్కడ లిమిట్ ఈ ఇంటర్వెల్ అనేటువంటిది తీసుకోకుండా ఇక్కడ ఒక ఓపెన్ బాల్ తీసుకున్నాం కాబట్టి z naught, and at every point in some neighborhood of z naught, some neighborhood of z naught, total neighborhood అని అంటలేండి, some neighborhood of అంటే ఈ పాయింట్ దగ్గర అంటే some neighborhood ఐఎమ్ టేకింగ్, ఈ పాయింట్ వరకే ఎనలిటిక్ అంటే ఇంత నైబర్హుడ్ కాకుండా అందులో కూడా some neighborhood ఐఎమ్ టేకింగ్. at that point the function is differentiable. Okay, but what is analytic function in the entire function? Analytic function ante everywhere in this z naught, if you take what is the z value occurs. ఇప్పుడు z naught ఈ విధంగా తీసుకుంటే ఈ నైబర్హుడ్ కదా, ఈ everywhere the function value is z, everywhere the function is analytic, then we call the function is a entire function. ఎవ్రీవేర్ ఇట్ ఈస్ డిఫరెన్షియబుల్. అంటే ఈ పాయింట్ దగ్గరికి వచ్చేటరకు ఏమవుతుందండి, దీనికి సమ్ నైబర్హుడ్ ఉంటుంది కదా, సమ్ నైబర్హుడ్ ఇట్ ఈస్ డిఫరెన్షియబుల్. దీనికి వచ్చేటరకు సమ్ నైబర్హుడ్ ఇట్ ఈస్ డిఫరెన్షియబుల్. దీనికి వచ్చేటరకు సమ్ నైబర్హుడ్ ఇన్ దిస్ డిఫరెన్షియబుల్. ఆల్ దిస్ టోటల్ ఎంటైర్ neighborhood the function is different. Everywhere, every point of z the function is suppose you take the point on the open ball, some neighborhood means what? It is going outside the neighborhood. And again on the open ball you take, again it should be some neighborhood of the point it is analytic. And so finally the function neighborhood is changing and it is increasing and increasing. What is the function you are taking? Completely in the domain it is differentiable, then we call the function is entire function. So therefore polynomial function is everywhere differentiable. మీరు x square plus 2x అనేటువంటి ఒక పాలినామియల్ తీసుకుంటే అది డిఫరెన్షియబుల్ అవుతుంది. పాలినామియల్ ఫంక్షన్స్ ఇన్ z square plus 2z అనేటువంటి పాలినామియల్ తీసుకున్నప్పుడు z square is differentiable plus 2z is also differentiable. Previous problem you see, this problem you see, therefore I given the polynomial function, you see 3z to the power of minus 5z square z cube plus 2z, everywhere it is differentiable. Therefore simply I am writing, okay, f dash z is equal to this one. But what is f double dash z? This is equal to 12 3 ja 24z square minus 15 2 ja 30 z. Again you differentiate this one, triple dash z 24 2 48 z minus 30. Again you differentiate this, what you are getting? 48. Again you differentiate this one, what you are getting? 0. So until the complete polynomial, it is a differentiable. Everywhere it is a differentiable. Therefore, polynomial functions are entire functions. That is my intention to tell. Okay? అర్థమైంది కదండి ఇది? Okay. So now some points I'm writing here. A function f of z is said to be analytic at a point z naught. Again I'm writing here, if f is a differentiable not only at z naught but at every point of some neighborhood of z naught. Okay, a function f of z is analytic in a domain if it is analytic at every point of the domain. ఇప్పుడు అర్థమైంది కదండి పాయింట్ మీకు, ఆ డొమైన్ మొత్తం ఇట్ ఈస్ డిఫరెన్షియబుల్, దెన్ వీ కాల్ ఇట్ ఈస్ everywhere it is in the complete domain it is analytic. The point at which the function is not differentiable, ఒకవేళ ఒక ఫంక్షన్ దగ్గర it is not differentiable, then we call it is a singular point of the function, For example, I will give entire function, a function which is analytic everywhere, then we call it is known as entire function. These all are definitions type lo nenu rasanu. For example, polynomial rational functions are entire. Okay, mod z square is differentiable only at z is equal to 0, so it is nowhere analytic. Only ante at z is equal to 0 the function is analytic, but other than z is equal to 0 the function is not analytic. I will discuss this one, I will show this one, don't worry. Mod z whole square is differentiable only at z is equal to 0, but the function is only the function is not differentiable is called singular point of the function. Some point, ఇప్పుడు ఇది z naught అండి, differentiable ఇది అంతా differentiable అయింది, బట్ ఈ z naught దగ్గర function is not differentiable అనుకోండి, then this z naught point is called the singular point. సార్ మీరు సింగులర్ పాయింట్ గురించి చెప్పిండ్రు, దెన్ వీ కాల్ దిస్ ఇస్ సింగులర్ పాయింట్. బట్ ఇక్కడ క్వశ్చన్ ఇది కాదు, ఈ రెండో దానిది ఏంటంటే అర్థము ఇలా తీసుకుంటే ఎట్ దిస్ పాయింట్ ద ఫంక్షన్ ఈజ్ డిఫరెన్షియబుల్. మీకు రెండు చెప్తున్నాను, ఓన్లీ జెడ్ నాట్ దగ్గర నాట్ డిఫరెన్షియబుల్ అయ్యి అంతటా డిఫరెన్షియబుల్ అవుతే ఇట్ ఈస్ the z naught is called the singular point and the function is differentiable everywhere but not differentiable at z naught అంటాం. ఇక్కడ రెండో పాయింట్ ఉంది చూడండి అమ్మా, ఇది చాలా ఇంపార్టెంట్. వాట్ ఐఎమ్ టెల్లింగ్, ద ఫంక్షన్ ఈజ్ differentiable at this point అంటే it is a analytic at this point, but all these points the function is not differentiable. This is example 1, this is example 2. Example 1 లోపల పాయింట్ దగ్గర డిఫరెన్షియబుల్, అంతటా డిఫరెన్షియబుల్ కాదు, అప్పుడు ఆ పాయింట్ ని సింగులర్ పాయింట్ అంటాం. కానీ ఇక్కడ డిఫరెన్షియబుల్ ఎట్ ఏ సింగిల్ పాయింట్, అదర్ దెన్ దట్ పాయింట్ ద ఫంక్షన్ ఈజ్ నాట్ డిఫరెన్షియబుల్, దెన్ వీ కాల్ ఇట్ ఈజ్ నోవేర్ డిఫరెన్షియబుల్, నోవేర్ అనలిటిక్ ఫంక్షన్. దిస్ ఫంక్షన్ ఈజ్ కాల్డ్ ది నోవేర్ అనలిటిక్ ఫంక్షన్. ఈ రెండు ఎగ్జాంపుల్స్ మీరు రాసుకుంటా అంటే రాసుకోండి, అంటే ఇదే డెఫినేషన్. ఈ డెఫినేషన్ ఇది పాయింట్ 1 అని పెట్టండి, ఇది పాయింట్ 2 అని పెట్టుకోండి, చాలా ఇంపార్టెంట్ అమ్మ. ఈ రెండు నాట్ డిఫరెన్షియల్ సింగులర్ పాయింట్ ఇదేమో. సో ఇన్ ద ఎగ్జామినేషన్ దే విల్ ఆస్క్ ఫైండ్ ది సింగులర్ పాయింట్స్. ఈ సింగులర్ పాయింట్ ని మీరు ఫైండ్ అవుట్ చేయాల్సి వస్తుంది. ఇది నోవేర్ డిఫరెన్షియబుల్, అంటే nowhere analytic. Nowhere analytic. Note, an entire is always analytic. Entire function ante everywhere differentiable kabatti automatically entire function is always differentiable. Entire function ani ochindi ante always differentiable. But differentiable every ikkada chudandamma, entire function is always analytic, differentiable and continuous function. ఎందుకు ఎంటైర్ ఫంక్షన్ అంటే ఏంది అసలు? మనం ఇట్లా నేర్చుకున్నాం. కంటిన్యూయస్, డిఫరెన్షియబిలిటీ, అనలిటిక్. మధ్యలో ఒకటి మిస్ అయింది. కంటిన్యూయస్, డిఫరెన్షియబిలిటీ, అనలిటిక్, ఎంటైర్ ఫంక్షన్. ఇప్పుడు ఎంటైర్ ఫంక్షన్ అయిందంటే ఇవన్నీ అయినట్టే కదా. కానీ ఇది అయిందనుకో, ఇది కావాలని ఏం లేదు, సిద్ధాంతం ఏం లేదు. ఇది అయిందనుకో, ఇది కావాలని సిద్ధాంతం ఏం లేదు. ఓకే, ఇది అయిందనుకో, ఇది కావాలని సిద్ధాంతం ఏం లేదు. అర్థమైందా? కానీ ఇది అయిందంటే మాత్రం an entire is always analytic, first one, differentiable, continuous function. But converse is not true. అంటే ఈ విధంగా ఉండదు, చైన్ ఎప్పుడు ఈ విధంగా. అనలిటిక్ ఫంక్షన్ ఈజ్ ఆల్వేస్ డిఫరెన్షియబుల్ అండ్ కంటిన్యూయస్. ఇక ఇప్పుడు 3, 2, 1 ఇట్లా కూడా ఉండొచ్చు. అంటే ఇక్కడి నుంచి స్టార్ట్ చేసిన అనలిటిక్, differentiability, continuous. But converse is not true. A differentiable function is always continuous. Malla 2, 1. But converse is not true. Itla undadu. Andukosame entire function ni kanukunnarante everything happens. 4, 3, 2, 1 ane level lo vachesadi chain. Cauchy-Riemann equations. These are very, very important equations. I am discussing Cauchy-Riemann equations. అయితే ఇప్పుడు మన క్వశ్చన్ ఏంటంటేనండి, ఒక ఫంక్షన్ ఇచ్చినప్పుడు అది ఎనాలిటిక్ కాదా? Is it analytic or not? If one function is given, then we want to check the analytic of the function. Means what? We want to check the differentiability of the function. But every function for this finding this differentiability is very complicated. You know that. మీ అందరికీ తెలుసు, ఎక్కడ స్టూడెంట్ ఎక్కడ వీక్ ఉంటాడు అంటే ఈ డిఫరెన్షియబిలిటీ ప్రతి ఫంక్షన్ కి కనుక్కోవడంలోనే ఫెయిల్యూర్ అవుతాడు. 90% ఇక్కడనే ప్రాబ్లం వస్తుంటుంది. అంటే అంటే sin x అనే ఫంక్షన్ ఇస్తే చేయగలుగుతాం, sin square x, cos square x, secant cube x అని ఇచ్చింది అనుకోండి, అట్లా పెద్ద ఫంక్షన్స్ ఇచ్చినప్పుడు we cannot find. అంటే it is a complicated and tedious work. So therefore this Cauchy and Riemann both are together worked on this complex variables, and they given one good theorem statement we are discussing. I am not discussing about this proof of this theorem, just you remember this one. The statement is given that suppose f of z is differentiable at a point at a point. F of z is differentiable at a point. F of z is a function. It is differentiable at a point z. Then at this z, the first order partial derivatives of u and v exist. U and v means what? F of z we write as u of x, u I, ఈ విధంగానే కదండి, u ప్లస్ iv అని రాస్తాము. F of z, f of z is equal to u plus iv. So this u దగ్గర v దగ్గర partial derivatives we will find. If these two are exist, partial derivatives exist, and Cauchy-Riemann equations are these two. This is the first one and this is the second one. Okay, once the derivatives are exist with respect to, because what is z? Z is equal to x plus iy. So that means what is u? U of xy. U is a function of xy. V is also function of xy. Ante kada, two functions. Then z is equal to u plus iv. F of z is equal to u plus iv. We will write z is equal to x plus iv. So u is differentiable means what? U is partially differentiable at x and partially differentiable at y. V is partially differentiable at x and y. Then dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. These two equations are satisfied. Then we call the function is Cauchy-Riemann equations, satisfies the given function. Okay, the function is satisfies the Cauchy-Riemann equation. So these two equations are called the Cauchy-Riemann equations. Equation 1 and equation 2. All of you please write.
ఇది నోట్స్ పంపిస్తారా సార్?
చెప్పండి.
నోట్స్ పంపిస్తారా సార్? ఇది
పంపిస్తానండి, తప్పకుండా పంపిస్తాను. కనబడుతోందా అసలు ఇది?
కనిపిస్తుంది సార్. కనిపిస్తుంది సార్.
మరి ఆ విషయం నాకు ఇందాకటి నుంచి చెప్పాలా కదానండి. నేను మీకు కనిపిస్తానని నేను క్లాస్ చెప్తూ పోతున్నా కదా.
కనిపిస్తుంది సార్.
నోట్స్ కనిపిస్తుందా?
కనిపిస్తుంది సార్.
మరి కనిపిస్తలేదన్నారు.
సార్ నోట్స్ పంపిస్తారా అని అడిగినాం సార్.
ఓకే అమ్మా, పంపిస్తాను, తప్పకుండా పంపిస్తాను. నోట్ పంపిస్తాను కానీ మీరు తప్పకుండా రాయాలి. ఇక్కడ మీరు నోట్స్ పంపిస్తారు కదా సార్ అని రాయకుండా ఉండదు. ఎందుకంటే ఇవి రన్నింగ్ నోట్స్ లో నేను చెప్పేటప్పుడు టాపిక్స్ వేరే తిరుగుంటాయి, మీకు నోట్స్ పంపించేది వేరే తిరుగుంటుంది. All of you please see this theorem statement. Is it visible? Visible undi kada? Only screen kanipistunda. అచ్చా టీమ్ స్క్రీన్ ఎందుకు వచ్చిందబ్బా ఇది Oh, okay. All of you, please see this one, the theorem statement. The necessary condition for a function f of z is equal to u plus iv to be analytic at all the points in a region R. And what is the necessary condition? Necessary condition only. This is not the sufficient. Only necessary condition. The necessary condition for the function is analytic means what? These Cauchy-Riemann equations are exist. If the Cauchy-Riemann equations are exist, then definitely this is the necessary that the function is analytic at that point, entire region. Okay, provided the condition is that just now I told you the definition of the Cauchy-Riemann equations. Dou u by dou x exist, dou u by dou y exist, dou v by dou x exist, dou v by dou y exist. So here you remember that if f is analytic in a domain D, then u v satisfies CR conditions at all points in D. CR conditions are necessary but not sufficient for analytic function. CR conditions are sufficient if the partial derivatives are continuous. అంటే ఈ పార్షియల్ డెరివేటివ్స్ అన్ని కూడా మీకు కంటిన్యూస్ అయినాయి అనుకోండి, డెఫినెట్లీ ద నెసెసరీ అండ్ సఫిషియంట్ కండిషన్స్ ఫర్ దీస్ టూ ఈక్వేషన్స్. అంటే ఈ రెండు ఈక్వేషన్స్ నెసెసరీ అవుతుంది, అప్పుడు సఫిషియంట్ అవుతాం. అంటే మీరు రివర్స్ లో వెళ్ళినా ఏ విధంగా చూసినా కూడా అంటే కంటిన్యూస్, డిఫరెన్షియబిలిటీ కంటిన్యూస్, ఆ విధంగా వస్తుంది. When these partial derivatives are continuous, then only. If these are not continuous, these partial derivatives, then the function is only necessary condition for Cauchy-Riemann equations. It is not sufficient for CR equations. So I will discuss some problems on this one, then you will understand this concept very simply. For example, all of you see how the Cauchy-Riemann equations we are considering, and we are solving the problem. Show that the polynomial function f of z is equal to z square plus z is analytic for all z. Ikkada what I will do, I am applying the Cauchy-Riemann equations. Therefore, f of z I will write in terms of u plus iv. అంతే కదండి. అంటే అప్పుడు u of xy I will write, v of xy I will write. These two things I will write. So therefore, f of z I will write as u plus iv type. So, but f of z is z square plus z type is given. So u plus iv means what? So this is z is equal to what? X plus iy I will write everywhere. Z is equal to x plus iy. So then f of z is equal to what? What is f of z? F of z is equal to x plus iy whole square plus x plus iy. This is what we will get. This is a plus b whole square principle. X square plus iy square is what? Iy square ఏమవుతుందండి? X square I square is minus 1, therefore minus y square అవుతుంది. Plus 2x 2i xy. You will get this one, or I into 2xy plus x plus iy. So these are the real values, these are the imaginary values. So these imaginary values one side, these real values I will write one side. X square minus y square plus x plus I times of 2xy plus y. This is I am writing imaginary values. Thus, what is u plus iy? You compare with these values with u plus iy. Definitely this portion is u and this portion is v. Okay, kabatti thus I will write u is equal to x square minus y square plus x and v is equal to 2xy plus y. Now we find the dou u by dou x, dou u by dou y. Okay, actually here dou u by dou x you want to find, dou u by dou y you want to find, and dou u by dou y you want to find, dou u by dou dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y, and dou v by dou x. These things you find, these four things. So that is dou u by dou x is equal to what? Dou u by dou x. You see that x is only we take dou u by dou x. This is partial derivative. When you do the partial derivative with respect to x, we treat as y as a constant. The constant derivative is 0. Therefore, this is the x square derivative 2x and the x derivative 1, 2x plus 1. And what is the dou v by dou y? Dou v by dou y ఏమవుతుంది? 2xy. Y with respect to y చేస్తున్నాం కాబట్టి 2x plus 1. Same కదా? Dou u by dou x is this one and dou v by dou y is this one. So here dou u by dou y ఏమవుతుంది ఇది? This is dou u with respect to y you are doing. So this is 0 and this is 0. This is minus 2y. Minus 2y I am writing. And dou v by dou x ఏమవుతుంది? ఇక్కడ dou u by dou y is equal to minus 2y. And dou v by dou x ఏమవుతుంది? మనకు 2y అవుతుంది. But minus if you take minus 2y out. So minus 2y is equal to minus dou v by dou x. So therefore, you see the Cauchy-Riemann equations. Dou u by dou x is equal to dou v by dou y. This is the first one. And the second one is dou u by dou y is equal to minus dou v by dou x. Minus dou u by dou x, dou y is equal to minus dou v by dou x. So Cauchy-Riemann equations are satisfied. Cauchy-Riemann equations are satisfied. Therefore, the function is what we want to show, that the polynomial function is analytic. So here CR equations satisfies. Therefore, the function is analytic. analytic. At all z. At all z. అంతే కదా, analytic at all z. At all z. Example 2. Show that f of z is equal to 2x square plus y plus I into y square minus x is not analytic any point. At any point. At any point అని అన్నారు చూడండి, not analytic. First we find the Cauchy-Riemann equations. For that one, dou u by dou x is equal to 4x. Directly I am doing here. And dou v by dou y, మీరు 2x square ఇక్కడ డైరెక్ట్ గా ఇచ్చిండు చూడండి అమ్మా, ఇది u ప్లస్ iv. ఓకే, కాబట్టి dou u by dou x is 2 into 2 4x. Okay, and dou v by dou y is 2y, dou u by dou y is 1, and dou v by dou x is minus 1. Therefore we see that dou u by dou y is equal to dou u by dou y is equal to minus dou v by dou x. But dou u by dou x, first condition is what? Dou u by dou x is equal to dou v by dou y. ఇది కావాలి. Dou u by dou x is 4x, dou v by dou y is 2y. Not equal, not equal. This is dou u by dou x. This is not satisfies. Only on the line y is equal to 2x. However, for any z on this line, there is no neighborhood or open disk about z in which f is differentiable. We conclude that f is nowhere analytic. And simply you write down Cauchy-Riemann equations are not satisfied, therefore the function is not analytic at any point. At any point. Some different problems we will discuss in the next class. This is the analytic of the function. Two problems I am showing here. So many problems we will discuss on this one. Many problems we will discuss on this one. Don't worry about it. I will tell everything again once again because this concept is a little bit of different and difficult also. So therefore, we will solve more problems on this one. Then you will understand this concept very simple. Okay. In the next class, I will discuss some problems on this one and where the function is not analytic, where the function is analytic. So what is the necessary condition? What is the sufficient condition? Which function for not the sufficient condition is not satisfying? This is also we are discussing for the Cauchy-Riemann equations for the problems in the next class. Okay. So any doubts, anything you want to ask, please. ఏమైనా అడగాలనుకుంటున్నారా? Yes. Anything else?
సార్ కాలేజ్ ఓపెన్ సార్ జూలై 1 నుంచి
తెలియదమ్మా, ఇంకా మనకేమి ఇన్ఫర్మేషన్ అయితే రాలేదు. Okay, thank you very much. I'm stopping here only the class.
థ్యాంక్ యూ సార్.
Thank you.